Introduction. The mixed alphabet cipher is another example of monoalphabetic substitution cipher, and the way it works is exactly the same as with those already encountered, except in one way. The difference once again is how we create the cipher's text alphabet, unlike all the ciphers we have seen so far, like Atbash, Pigpen, Morse, Shift, and Affine. The mixed alphabet cipher does not use a number as a key, but rather a key or key phrase.
Encryption. With this cipher, rather than performing a mathematical operation on the values of each letter or just shifting the alphabet, we create a random order for the ciphertext alphabet. In the table below is one such random ciphertext alphabet. A mixed ciphertext alphabet, where the order of the ciphertext letters has been selected randomly. Clearly, it is very important to ensure that each letter appears in the ciphertext alphabet once and only once, so that two plaintext letters are not enciphered to the same ciphertext letter. With the ciphertext alphabet generated, the encryption process is the same as with every other form of monoalphabetic substitution cipher. That is, each with the ciphertext letter that has been assigned to that plaintext letter, although it is possible to generate a completely random ordering on the letters of the ciphertext alphabet. As in the table above, it would involve both sender and recipient to remember a random string of 26 letters, not an easy task, for the reason, as with most ciphers, a keyword is often used. The ciphertext alphabet is then generated using this keyword as follows. The keyword is written first, ignoring any repeated letters, and then the remaining letters of the alphabet are written in alphabetical order. For example, if we took the keyword code HS, we would get the alphabets given in the table. So if we encrypt the plaintext attack with the keyword code HS using the mixed alphabet cipher, the letter A ciphers C, the letter T ciphers T, the letter T ciphers T, the letter A ciphers C, the letter C ciphers D, and the letter K ciphers I. So, the encrypted letter of the plaintext attack with the keyword CODEHS using the mixed alphabetic ciphers is CTTCDI.
Good day, sir. I am Gracial Joy Sanem Macinto, and I will going to discuss how decryption mixed alphabet ciphers work. As with the other ciphers of this type, the decryption process is similar to the encryption process. The first step is to generate the ciphertext alphabet in the way as with the encryption process. We then do the opposite, finding the ciphertext letter in the cipher alphabet and replacing this with the corresponding plaintext letter. In here, we type the CEJMRJW to the ciphertext box beside the decrypt box and type the keyword in the keyword box. Our keyword is mathematics. If you click the decrypt, it will show the encrypt or the plaintext. And how do the system encrypt the message? Just like this. First, look for the ciphertext in the table, and if you find it, just look at what is the above letter, and that will be the answer. Just like this. The column that corresponding to C is G. So G decrypt to C. So the first letter in the message is letter G. The column that corresponding to E is E. So E is decrypt to E, so the second letter in the message is letter E. The column that corresponding to J is M. So M is decrypt to J, so the third letter in the message is letter M. The column that corresponding to M is A. So A is decrypt to M, so the fourth letter in the message is letter A. The column that corresponding to R is T. T. So T is decrypted to R, so the fifth letter in the message is letter T. The column that corresponding to J is M. So M is decrypted to J, so the sixth letter in the message is letter M. The column that corresponding to W is W, so W is decrypted to W, so the last letter in the message is letter W. So our plain text now is GMAT MW with the keyword mathematics, and that's how mixed alphabet decryption works.